Hey everyone, what's up? Are1or0 here. So today we continue with AWS Cloud Security series. I think this is the 7th video if I'm not mistaken. And we're gonna go through a playground that's called AWSGoat from INE Labs. It is called a damn vulnerable AWS infrastructure. It has the most common misconfiguration vulnerabilities on different technologies like web application vulnerabilities from OWASP Top 10, some misconfigurations on different AWS services like IAM, EC2, ECS, etc., etc. We also touch on an exploitation technique on container escape. So it's a combination of different vulnerabilities, not just focusing on AWS misconfigurations. So I really like this one. If you were watching my videos since the beginning of this AWS Cloud Security series, basically I'm focusing on different playgrounds. I have like a list that I'm going through. And I have to say, this is my favorite so far. So yeah, enough with the chit chat. If you're ready, let's jump right in. So here is the vulnerable playground, and the setup is super simple here. What you need to do is you just need to fork the repository in your GitHub account. After forking the repository, you need to set your AWS credentials under GitHub Actions, secrets, and start Terraform with Terraform apply command. So let's see it in action. What does it look like? First of all, I have an administrator user on my AWS account. I created security credentials for it already, so we will use this later. I'm just forking the repository on my GitHub account, and then we will go to GitHub Action Secrets and we'll add these two values with my admin user's security credentials with the access key and secret key. So the values are just written like that: AWS access key and AWS secret key, and the values would be coming from the security credentials of the admin user that I have. So once we create that, we will go to the actions tab, and we will start with Terraform apply. So once this is completed, I'm just gonna skip it because it takes a while. So once this is completed, we're gonna check the URL for the vulnerable application, and we will start the first exploitation phase. It also gives you the diagram, like where we're gonna start. There are load balancers, what kind of like services or what kind of infrastructure do we have in here, the web application, command execution, file upload, Docker breakout, all kind of different roles that we will use in IAM, misconfigurations, etc. So let's go to the web application before we jump into all of these exploitation techniques. We got the application URL from there. We will go there. There's a login page. Of course, when you see a login page, the first thing that you will do is try to exploit whether XSS or SQL injection to see any vulnerabilities. So first I'm sending the request for a non-existing user so that I can intercept the request. And I did it in two different ways. I send it to SQL map, and I also send it to my Burp Pro for scanning. And Burp Pro was faster than SQL map, and it gives me immediately that there's an SQL injection here. I'm also showing the SQL map. I just saved the request in the log.reg file, and I'm giving it with the -r parameter. Right, so we just send the request here with the payload that we got from Burp for SQL injection, and it gives 300 to redirect after login. As we can see, we logged in as a user. Perfect. So we're going to look around for different functionalities, and under reimbursements, it gives you the option to upload a file. Of course, our hacker minds immediately goes there. What can I do here? Let's see. This is a PHP application. Well, it's a shocker. Let's create a PHP reverse shell with one-liner. So yeah, we're just going to create a very simple one. Just choose any options here. It doesn't matter. Just add some values here. End of September, let's say, amount something, and upload the PHP file. When I say that, I'm getting an error message, but this never stops us. Obviously, we're going to do file extension bypass. So I'm just going to send that requested fail to my repeater, and I'm going to check what kind of content file type we're having here. As you can see, content type is text PHP. Of course, it's detecting it. It's not good. So we can try to upload an image slash JPEG file. And as you can see, 302 response. So that means it's probably we uploaded the file. When I check again, I'm seeing the file here. Perfect. Let's open the file. And at the parameter that we added in a one-liner, which is CMD as far as I remember, and add a simple comment like ID or who am I, and it's going to give us an RCE in this way. Perfection. So what I'm going to do is I have an EC2 instance here, or if you have any server that is a public IP, that's also fine. I'm just going to reach out my EC2 instance and create a one-liner for me to get a reverse shell. So we can just use the Python one-liner. Depends. You can also check with the command which Python using an RCE to see if Python's installed. That's my way of doing it. I'm just listening on the port, and I'm gonna send the Python one-liner to get a reverse shell using this RCE. Let's send that Python one-liner, and then we get a reverse shell. Let's wait a bit. Here we go. We got the reverse shell already. Very cool, very data. So whether you can run a tool like linpiece, but the first thing I generally do is sudo-l to see if there's any applications I can run as root, and we will find an option here. Let's see quickly. We can also check for the processes, but again, linpiece will do all of this work for us. I'm just showing a few options if you want to do it manually. Another thing that I realized is when I check for the environmental variables, I found some URLs, some metadata, some endpoints. So this is something I will definitely use later for container metadata URI. That's something to keep in mind. But these would again come with the linpiece as well. It checks for environmental variables. So I'm just showing a few manual steps to show what we will actually use, because linpiece is given a huge output. So it may be confusing to people who watch this video, like where are we checking? As you can see, we will use this metadata later. Let's check with sudo-l comment to see if there are any comments we can run as root. This is vim. Obviously there's a vim bypass to be root, so this is super simple. Bin bash or bin sh, anything we write, you became root. This is a very simple vim privilege escalation method basically. Now I can go to that URI that I got from the environmental variables, and when I call it, I can actually get the credentials. Let's see. Let's go there. When I send that, as you can see, I'm getting the credentials in a JSON format. So we can just parse this a bit and get the access key, secret key, and the token, and add it to our AWS credentials with a new profile. I just did it now. So we can also call it with AWS STS get caller identity to get the username, role name, or account ID, these kind of details. So let's do it for the current profile, and we're getting it rolled there. So that's one thing. Let's go back to our ECS and check for any other juicy information using linpiece, which is a Linux privilege escalation tool. It's a bash script, so you can just use pipe sh basically to run it without actually saving it and change the permissions, etc., etc. So just a little trick. So it will give us a lot of information like that. So there is another tool that I'm installing in here for AWS credentials to see which kind of permissions do they have. You can also use any other tool like Pucko or something, but this one is quite cool. So you just give the access key, secret key, token, whatever you have for the profile, and it just gives you a very clean output. I like this one, so I provided in here. You can also use this tool. So it gives us some stuff about secrets manager. I'm seeing like list secrets, get secret value, these kind of things that I can do with the current profile, which I will use. So let's see, with the secrets manager, list secrets for any secrets that are existing using this profile. You also need to specify a region. I always forget that. If you watch my previous videos, it's always the case. We're finding some secrets from my previous videos, so ignore them. The last one is the valid one for this exercise. And we found the secret here. We can definitely get the get secret value because we were also eligible to run this comment from the previous tab where we checked the IAM permissions. Once we do that, we will also get root credentials. So that's another juicy information that we will get from here. We still need to do container breakout in the first tab because we are still stuck in a container. You can just see this information in the output of LinPiece. So we need to do container breakout to see the host and reach there. So let's go through the output to see what kind of information we can use for the further exploitation. And as you can see, the current shell capabilities, we are basically seeing that we have capsys ptrace capability. And in this way, we can see the host processes. If you scroll down a bit, you can also see all this information. And when we look at the processes, there is a Python process, Python HTTP server listening on a certain port, I think 31452. Yeah, I'm seeing it now. So I'm assuming this is the connection with the host. We're also seeing the container IP and then the IP address here, like 0.2. So I'm assuming the host IP is 0.1 then. You can also verify the IP address with the ifconfig comment. If ifconfig is not installed, you can check with IP ADDR. So that's that. We can also check for what's there on this port 31452 on the host, not with the IP address that ends with 2, but the one that ends with 1, which should be the host's IP address. We can use curl for this. After that, we can try to inject the shellcode onto any of the host process. And for that, we can go to exploit.db, and the first thing that we found, we can already use this one. It basically binds a shell on port 5600, 5600. That's that. And then we need to also use the injector, and this one is the most popular one that you can use. That's a C code. We just need to update the shellcode in it with the shellcode that we got from exploit.db. So we're just gonna update that C code very quickly with our own shellcode from exploit.db. Let's do that. And then we need to compile the C code, and GCC is already installed on the container, so we can use that. We just need to transfer this file to the container, and we can easily do that with curl. Curl is installed, or otherwise this is another method, EOF, like that's another Linux method to copy and paste. But that can create indentation error. So if that creates a problem for you, you can just go and create it. You can just transfer it with curl from your EC2 instance, for instance. Yeah, mine created a problem here when I was using this method. So let me try it one more time, but it should work on the second run. Yeah, I just did not click on enter at the end of it. Anyway, it doesn't matter. The file looks good now. So the next step is we need to find a process that's running on the host so that we can inject our shellcode there. And then you can just choose any of these processes basically, and just choose one and try to inject the shellcode using the process ID. So we compiled the code, just change the permissions, go back to the process list, find the one process that's running on the host, first the container D, and then find the process ID and just run the binary that we compiled, and get the shell like that. As you can see, we just get a shell in this way in the host system. Since we break out of the container, we can now get a reverse shell on the EC2 instance, so that this is more like a stable shell that we can play around here. Once we do that, we can look for metadata API, security credentials, so that we will basically get the next credentials for the next user or next role, where we can try to escalate our privileges for the next steps. So as always, we are using curl for this purpose. Same URL, same endpoint, 69254, 169.254, latest metadata, IAM, security credentials. And then you get the role. You need to add this to your endpoint as well, where you will get the AWS credentials for this role. Let's run this again. Perfect. We get the access key, secret key, and token. We just added to our AWS credentials file, which I'm doing at the moment, and call the profile ECS instance profile. Perfect. And then, as always, the same story. We are just enumerating IAM permissions on this profile. First, we are verifying it with STS get caller identity, and then we can run the same enumerate IAM Python script, so that we can see what kind of permissions do we have. So let's run it quickly. Access key, secret key, session token, just these values that we grab from the host metadata API. So let's see. Adding access key, secret key, and session token. Let's copy and paste that, and it will start enumerating for us what kind of permissions do we have. Once it starts listing down, we will realize that we have permissions to list policies. Let's scroll down a bit more, and you can see it in here, right? List policies. So let's try it out, and let's see what kind of policies we will find. So it's a classic comment with AWS IAM list role policies or list attached role policies. You can check for both. And first we are starting with list attached role policies. You're writing the role name. We already have this one from metadata API. You can just write there, and profile that we just named with the credentials. And we're finding a couple of managed policies. You can also look for inline policies with the list role policies comment, but we are not going to find anything from there. So since there's this IAM full access policy, I want to use that one for privilege escalation. So as you can see, with the inline policies, we don't find anything. So we can try to get different roles. So we have a permission boundary here, so we cannot create a new policy with excessive permissions. So that's one way we could have escalated, but we are not able to. So next we can check for this AWSGoat instance boundary policy. When we check that, we see the default version is 1. And then we can use get policy version comment to see what kind of actions are we allowed to do with the effect allow on this policy. Let's see the details, and then I will see a bunch of things like EC2 run instances, so we are allowed to run EC2. There's IAM pass role, so we can pass existing roles to the EC2 instances. There is all actions allowed on SSM. That means we can run comments on the EC2 instances as well. So there are a couple of cool services and actions allowed, which I can use for my privilege escalation. So once we do that, basically we will try to run a new EC2 instance and pass a role with hopefully admin privileges or like a very privileged role. So let's check for roles first to see if we can find a role with our desired permissions. And for that, we can use IAM list roles command. Of course, we will attach the profile. Once we do that, we will find a role called EC2 deployer role. We can check policies attached to it. So when we check for attached role policies for this role name, we're gonna find a policy, and using the current version of the policy v1, we can check for which actions are allowed on which service. So let's do that quickly. Once we do that, we will see that we're allowed to do any action on any resources. So that's great. This means this is like a admin privileged policy. So that's great. So that's basically the role that we needed. Perfect. Next, we need an instance profile with this role attached to it. Hopefully we are lucky so we can find one. And when we go through that command, we will find the EC2 deployer instance profile with this role attached to it. Perfection. So we're taking a note of the instance profile name and the role name that we will use later. Since we are allowed to run an instance, that's what we're going to do. First, I'm writing the parameters that we're going to use. I'm not writing the values for parameters, so you can see the big picture. And then we will slowly insert our values here. So we're going to run instances. We're going to define subnet ID, image ID, IAM instance profile, which we already have, instance type, t2.micro, the free version. We need to define the security groups. We will again check this one again in a second. We need to give the profile, we need to give the region. Of course, these are classic information as well. So if you want to check the subnets and security groups, very simple command, AWS EC2 describe subnets, and then the profile and region you attach. Once we do that, we need to go through the list to find the proper subnet that will fulfill our purpose here. And the other comment that we need to run is AWS EC2 describe security groups. Again, the profile and the region needs to be added as well. And then we need to find this image ID, AMI. You can just go and say create a new instance, and it's easily giving you the current value because it's updated. You can't just use anything that you can find online. You need to go to AWS console to find that. So we're gonna type the image ID here. We need to find the subnet ID and security groups as well. We'll just go through the list and find the appropriate values here. So once you make sure that both the security groups and the subnets are part of the same VPC, we are good to go. Then we will run this command to run a new EC2 instance. Once everything is all right and we create a new instance, we're gonna grab the instance ID from the successful output that we get. So what I'm gonna do next is I'm gonna use SSM to send comment on this EC2 instance. That's the syntax for it. AWS SSM send comment. We need to give the instance ID, the document name, comment, parameters, etc. There are a few options that we have. We will need the help of the AWS documentation to make sure that we are on the right track. You need to give the region, of course, the profile as well. Again, I'd first give the options so that we can fill them together, otherwise it may be confusing. Same profile, of course, we are copying and pasting here. And for the comment, I will just write it ID, like the simplest comment that I can get. For the document name and also the query, I'm checking the AWS documentation to see what I'm supposed to write. Let's type it in here, AWS run shell script, and this is the query comment ID. Once I do that, I get a comment ID, which I can use to invoke the comment, basically. I will also run another comment to see if it's properly working. But like I said, like just SSM send comment is not going to give you an output. First, you need to create that comment, basically, and then get comment invocation to get the output of this comment. So let's check the second one, for instance, for the IP address information. You need to give the instance ID again, and profile and region, like the classic things. When you do that, I think I did a typo somewhere. Oh yeah, it's not instance IDs, it's like plural, it's supposed to be ID. I'm a typo person, I always do typos, so but that's how you learn, right? So yeah, standard output content that shows us the IP ADDR comment output, so that's great. That means our comment execution is working. Next, we're gonna inquiry the metadata API to get the credentials. We can just send this same endpoint that we always use for metadata API security credentials information. So we send the comment and we invoke it, and as you can see, we get the credentials again. As perfection, then we need to add this to our profile once again with this privileged role. Once we do that, we gain admin privileges. You can just add it to your AWS credentials file, or you can do it like this with the export. When we check for get caller identity, we're getting the account ID and this assumed role, as you can see here, EC2 deployer role, which we use during the exploitation. From there, you can do admin actions like create a user, setting credentials for it, accessing it in the console, attaching a user policy like administrator access policy. We're the privileged user right now, so you can do whatever you want. Right, while I'm typing in the background, let me wrap it up. I think it was one of the best playgrounds I have ever worked with for these YouTube videos. It definitely combines so many different technologies on the website using OWASP Top 10. And then the container breakout, just one technique. Obviously there are so many more, but it's a cool one, with the process injection. And then there are multiple misconfigurations on the policy side, IAM misconfigurations, running an EC2 instance, running different comments on SSM, and then the secrets manager. So many cool things that you need to know to combine and find a strategy. So I hope that you enjoyed this video, guys. Please drop a comment. There are definitely more resources that I want to create videos on AWS cloud security. Right, so I will continue creating and publishing, and yeah, please drop a comment, and I'll see you in the next video. Cheers, guys.